Today we're starting our unit on planar figures. That means they're 2D. An example would be a triangle, or maybe a hexagon, or a parallelogram. So today we're looking at the property of parallelograms. How do I use the properties of parallelograms to find missing measures? Learning intention. I'm learning to find missing measures by applying the characteristics of quadrilaterals. So your warm-up question says to solve the triangle. That means you will find all the sides and the two missing angles. So pause the video and see if you can solve that triangle on your own. Well, I do hope you tried. It's the right triangle, so we can use the Pythagorean theorem. We are looking for a leg, so x squared is equal to 56 squared minus 52 squared. Of course, the opposite of squaring is square rooting. So x will be equal to the square root of 56 squared minus 52 squared, and we'll see if that is a Pythagorean triple or not. And you get 20.78, so it's not a Pythagorean triple. It's about 20.8. Okay, now for the angle measures. If we start with the one that has a question mark, the two pieces we know are what? Adjacent and hypotenuse. That is your cosine. So the cosine inverse of 52 divided by 56 is approximately 21.8 degrees. Okay, that takes us to the last angle. To find that last angle, we know that these two added together have to be 90 degrees. If this one is 21.8 degrees, then I'll take 90 degrees minus 21.8 degrees, and I will get 68.2 degrees. So now we have found all of the missing measures. So what are the properties of a parallelogram? Well, let's start with the symbol. The symbol for a parallelogram is a parallelogram. A parallelogram is a what? We're going to start out by using the numbers of sides. It's got 4 sides, so that makes it a quadrilateral. Okay, do you know what the sum of the interior angles of a quadrilateral equals? Well, a triangle is 180 degrees. Remember, you can cut a quadrilateral in half, and you have 2 triangles. So 2 times 180 degrees is 360 degrees. Okay, what about the opposite sides of a parallelogram? They are two things. One kind of leads to the other. So the opposite sides of a parallelogram are what? Well, parallel for one. The symbol for that are 2 lines like that. And what else? Congruent is the other. There's the symbol for congruent. Okay, what about opposite angles of a parallelogram? What do you think? If you said that they were congruent, you would be correct. Diagonals of a parallelogram do something to each other. Bisects. Okay, so let's get started. We want to prove that they do bisect each other. So we're given ABCD as a parallelogram, and we want to prove that segment AE is congruent to segment CE, and segment BE is congruent to segment DE. 99% of the time we start with the given. So as we get ready to prove, 99.99% of the time we start with what? We start with the given, and we're given that ABCD is a parallelogram. Okay, now what does that mean? Well, it means that your opposite sides are what? They are congruent and they're parallel. So, second thing we need to do is to draw those two diagonals, AC and BD. This is what we call construction. We're doing it because we need those pieces to help us prove. Okay, how do we know that side AB is parallel to side DC? Well, that is the definition of a parallelogram. Okay, I'm going to use my symbols because it's much easier to do than write that big, long word out. Okay, so now the next one is step 4, or statement 4. If you look over here, the reason given are alternate interior angles. Okay, we've looked at A and we've looked at C. What are our alternate interior angles? Here's my transversal this way. Here's my transversal this way. So if you're looking at it, 1 and 4 would be alternate interior angles. 2 and 3 would be alternate interior angles. So now we need to list that. We know that angle 1 is congruent to angle 4. And we also know that angle 2 is congruent to angle 3. Okay. So it says now that opposite sides of a parallelogram are congruent. What two sides are we talking about? AB and CD. So segment AB is congruent to segment DC. If you're looking, we've got this is congruent here, and then we've got this angle and this angle, this angle and this angle. So we know the two triangles are congruent by, is it hypotenuse leg, side, 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 angle, side, angle, side, angle, 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 side. If you said angle, side, angle, you would be correct. Now, I've gone to all that work to prove two congruent triangles. What do I use next? Remember that long string of letters. Corresponding parts of congruent triangles are congruent. CP, Now, let's let our reader know that we are finished. I'm going to put that little infinity symbol there. And we are done. So, if you're still struggling, back the video up and watch it again. Okay, so let's look at the parallelogram. Find all the missing measures, and you can do this without any math at all. Opposite sides are what? Congruent. This one's 16 centimeters. This one is also 16 centimeters. If this one is 25 centimeters, the opposite is also 25 centimeters. Opposite angles are what? Congruent. If this one's 72 degrees, this one is also 72 degrees. If this is 108, this one is also 108 degrees. Done. Now, the guitar has markers on the fretboard that are shaped like parallelograms. Did not know that until I read it. Find BC and the measure of angle B. So let's look at BC first. What do we know about opposite sides of the parallelogram? They are congruent, so we'll set it up congruent. 13x minus 7 has got to be equal to 9x plus 5. Nine x is smaller than 13x, so we'll subtract 9x from both sides. 13 minus 9 is 4, so this is 4x minus 7 is equal to 5. Now, I need to add 7 to both sides. 4x is equal to 12. Divide both sides by 4. And x is equal to 3. So if I'm looking at BC, that is 9x plus 5, 9 times 3 plus 5. 9 times 3 is 27, plus 5 more will be 32. And that will be 32 units. We don't know what kind of units it's in, so we can't put centimeters or feet or whatever. Okay, now the measure of angle B. Once again, we know opposite angles are congruent. So, 7y plus 45 degrees is equal to 13y minus 9 degrees. 7y is smaller than 13y, so I'll subtract 7y from both sides. 45 degrees is equal to 13 minus 7 is 6, 6y minus 9 degrees. Okay, I need to move the 9 over. Add 9 to both sides. 45 plus 9 is 54 is equal to 6y. Divide by 6. And 9 is equal to y. Okay, hopefully you were able to keep up as we went through that. Now, how do we find the measure of angle B? Well, we use substitution. 7y plus 45 degrees is equal to 7 times 9 plus 45 degrees. 7 times 9 is 63 plus 63 degrees plus 45 degrees gives me 109 degrees. And we are done. So, you're supposed to pause the video now and see if you can do the last one on your own. The last one is identical to what we just did. So, pause the video and see if you can do the next one on your own. It's identical to what we just did, except with different numbers. Well, I hope you tried on your own. Angle D and angle B are congruent, so we know that 5x plus 15 has got to equal 8x minus 21. Solve for x. 5x is smaller than 8x, so I subtract 5x from both sides. $15 is equal to 3x minus 21. Add 21 to both sides. $36 is equal to 3x. Divide by 3, and x is equal to 12. Now I've got to substitute it in. Does it matter which one I use? No. So I'm going to use the 5x plus 15, and that's equal to 5 times 12 plus 15, and this is degrees. 5 times 12 is 60, plus 15 is equal to 75 degrees. Okay, using that same idea, we know that opposite sides are congruent. So we know that 4x plus 3 has got to be equal to 7x minus 15. 4x is smaller than 7x, so I'll subtract 4x from both sides. Three is equal to 3x minus 15. Now I have to add 15 to both sides to get rid of my negative 15. Three plus 15 is 18. 18 is equal to 3x. Last step is 2. Divide by 3. And 6 is equal to x. But that doesn't tell me the length. I've got to use substitution. I think I'll use 4x plus 3. So that is 4 times 6 plus 3. 24 plus 3, which is 27. And we still don't know the units, so we'll just simply put units. So hopefully this makes sense and it's not too difficult. So how do you know when you're successful? When you can use the characteristics of parallelograms to find missing measures. Parallelograms. Remember, it is that parallelogram symbol and missing measures. Okay, I want you to think again. We've got these two parallel lines. If we're looking at alternate interior angles, we know that those are congruent. What about same side interior angles? What do I know about angle B and angle C? They are supplementary. So that is what we will be discussing next time.